In this video, we are going to model some very basic linear and exponential equations. And so I know most of you guys already have this, but let's just talk through it real quick anyway. First thing I'm going to do is I'm going to center all the information because it's going to turn out to look a little bit better that way. But basically what we're going to talk about is an X and a Y modeling process, right? This is your classic Y is equal to X linear model, right? And so we can modify this in some way with a coefficient. And in the past, you have learned Y equals mx plus b, right? But at the collegiate academic level, we don't want to use that m, and we don't want to use this lowercase b. What we use are these coefficients. Y is equal to b sub 1, which is the coefficient for x, or in our case, it's going to be x sub 1. But you know, if you just have the 1, nobody really uses it. It's fine. Plus b sub 0, right? Which is a coefficient mirroring y equals mx plus b. That is the what do you call it in Algebra 1 back in high school? It is the thing where you cross the intercept, right? The x-intercept. And so, you know, if we were to do this, if I do 1y, we get 1x. And if I get 2y, then we get 2x, because obviously I'm doing a plug and play thing here, right? Y is equal to x, right? So I'm just going to go 1, 1, 2, 2, 3, 3, and so on. That's fairly easy to put together, but we need to make some space for the coefficient. So let's go ahead and do exactly that. I'm going to insert a line between these guys. I'm going to call this b sub 1, and I'm also going to call this x sub 1, just so that we're all on the same page here. And to make this a little bit clearer, why don't we create some lines so we know what kind of behavior we're expecting from each side of the equation. Because that's what's happening over here, right? We're saying, hey, look, here's the equation. This is the y side. This is the x side. And whatever we calculate on the x side, it's going to predict the y. And this is one place where it's a little bit different than what we did in high school, right? It's not y looking to the right, mx plus b. It's what's happening on the right side, mx plus b, which tries to predict y. The directionality of this movement matters, right? These are going to be our independent variables, independent, and the y on this side, this x is kind of getting in the way, is my dependent. Y depends on what's happening on the other side of the equation, right? So here we're going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And depending on how I build that y is equal to, notice that I use an equal sign, and I'm going to use whatever's in, you know what, let's put something in here, 1, 1, right? Because we're all our b sub 1s are going to be exactly the same. That's fine for now. So this is going to be equal to m, or in our case, b sub 1, right? Because that's how we're going to write this, times x sub 1, where the next one, if I just copy paste this down, control D, is going to tell us the same thing, this one times this one. And this is super obvious and it's super easy. Here, if you don't know this trick, let me show you one of my favorite tricks. You see that green square in the bottom right-hand corner? You can just grab it and drag it down, and bam, it gives you all of them all at the same time, right? Isn't that wonderful? It's absolutely the best. I like to say in class, it's the coolest, right? How cool is that? It's the coolest. Let's change this color to red so that we know that that's our y. I suppose I should change the y as well. And whatever happens on the left-hand side here depends on my independent variables over here. That's why we call the y our dependent variable, right? Dependent, because it depends on whatever happens on the other side. And you know what's going to happen next. We can actually change, let me make it here too, right? And if I take this, let me highlight this in some other color so we know what it is. And then I'm going to say equals c sub 1 You can $sign, or you can just hit F4. It'll do it for you. And then I'm just going to do them all the same. So that way I don't have to fix 10 of them. I just fix the one on top. Clearly you saw the Y's shift to larger numbers. No surprise. That guy has a steeper slope of 2, right? M is equal to 2, but we don't like M. Whoops. We like B sub 1. This is B sub 1 is equal to 1. B sub 1 is equal to 3, and all the other stuff you did in high school. Not a huge surprise here. You know exactly what happens if I hit some super huge slope or whatever. Let's go back down to 2, just so we have something to play with. There's a couple of different really basic things that's going to be different here when we use a program like Excel. And this is a model, right? Our model is y is equal to b sub 1 times x, in this case, x sub 1. We are going to be model building. You want to be model building, because once we learn how to do this, then it's relatively easy to graph. I can take this guy, and I can take this guy, and I can insert a recommended chart. We do this as a bar graph, we do this as a line graph. This one looks pretty good here. No, the problem here is that my y and my x's are on the wrong side. So this is an Excel problem. I'll show you what I mean. Excel always takes whatever's on the left, this first column. I'll show you what I mean. Let's just do a very simple line graph and see what happens, right? That's the y, and that's the x. I don't want the x, I want just the y. And actually that works out quite nicely. So there's our line for that one. Now let's do another one just like it, or more to the point, let's modify this by doing a different type of model. Let's do x1 squared, right? So I'm going to do x sub 1 squared and see what happens next, right? So this is going to be equal to x to the squared, right? And that's 1. I can drag this down. And now I'm going to do them both, right? So let's get rid of this graph for a second, and let's graph these two. Insert line graph, just the most basic one. And there we go. Again, no surprise. This is y is equal to x squared. This is equal to, let me delete this. This is y is equal to x, and we have a linear relationship. Again, no surprise to you guys. This is a linear relationship because it is not exponential, and we have an exponential relationship because obviously it's exponential. Which one would we prefer? Well, if we're talking about investments, well, obviously I want an exponential chart, and that's something we can do later in the semester, right? A couple of real basic things I want you to take from this. Number one, we are using classic basic algebra 1 stuff in order to, that shouldn't be there, in order to create models. I want you to think in terms of model building. So I don't want to solve that one problem using linear equations. I want to solve multiple problems, right? You can then go into a program like Excel, and this here is the model, the one that says C3 times D3. This is B sub 1 times X sub 1, right? And you can make these as complicated as you want. You can do, let me see, you can scroll down a little bit. You know, you can do y is equal to b sub 1, x sub 1, plus b sub 2, x sub 2, plus b sub 3, x sub 3 squared, plus b sub 0. I mean, and it gets absolutely carried away. One of the things we'll do in stats 2 is called a regression, where we try to create this. Actually, we'll do it later this semester, and we'll point it back to this one. And I'll show you how to take basic data and try to point it back. So we've got to go through this once. And then later in stats 2, way down the line, we'll do a multiple regression, where we will take 1, 2, 3 different variables and do them at the same time. So some of the stuff that you've seen in high school algebra actually is very, very useful. But the way that we get at it comes from a place where we start to push data around. And in order to manipulate, or I shouldn't use the word manipulate, in order to push data around, we need to create models. And one very easy, very basic way to do that is to create a model where we see the movement as x increases, right? Y is equal to mx plus, in this case, we didn't do a b, but you could, right? Mx plus b, right? And then the model gets applied to all the y's. No, the model gets applied to all the x's, right? Because x is independent, it stands alone. What we're trying to do is take this and calculate this, take this and calculate that, take this and calculate that. All the calculations happen on the left-hand side. All the calculation, all the prediction happens at the y.